Hello friends, today we start with this question. In this question, the question asks about the major product of the following transformation. Here they give one cyclic ketone, react with metachloroperbenzoic acid, and in second step they treat it with lithium aluminum hydride. If we know about metachloroperbenzoic acid add one oxygen atom in between carbon-carbon bond adjacent to carbonyl group. So here we saw two carbons are present attached to this carbonyl group. So metachloroperbenzoic acid attach one oxygen here or here. So if we follow the mechanism, we get our answer where metachloroperbenzoic acid add oxygen this carbon atom or this carbon atom. To understand the mechanism in easy way, we represent this carbon atom in our mechanism. We represent with R2, and this carbon atom we represent this carbon atom in our mechanism with R1. And we all know metachloroperbenzoic acid structure like this. Here one benzene ring is present, here chlorine group, here one carbonyl group, oxygen, and one hydrogen is here. It means it is metachloroperbenzoic acid. Represent this group with R double dash. So this is the metachloroperbenzoic acid structure. In this structure, we take this part and we represent this part by R double dash in our mechanism. And this carbon atom we represent with R2, and this carbon atom represent with R1. So here let's start this mechanism. First we take our cyclic ketone like this. Here we take R2 and here we take R1. First we treat it with this metachloroperbenzoic acid. Here we draw this group R double dash. One hydrogen is present. In step 1, this oxygen electron attack on this proton and take this hydrogen atom, and protonated ketone is formed, and here percarboxylate ion is formed, which is reactive nucleophile. So here we saw after the step 1, here one protonated ketone is formed. Here one protonated ketone is formed, and here nucleophile is formed, like this bond electron shift to this oxygen atom. So this is our carboxylate ion, which is very reactive nucleophile. So in step 2, this electron attack on this carbonyl carbon, and this pi bond electron shift to this oxygen. So in step 2, nucleophilic attack on the carbonyl carbon and form one intermediate. Here one intermediate form. After step 2, here electrons come again. Here R1 at this carbon atom attach with this oxygen, and here oxygen, and this is our R double dash group. So this is our intermediate. In step 3, these electron return to this bond and again form double bond, and which carbon group attached to this oxygen we check in our given ketone. Here R2 is a 3 degree ketone, 3 degree carbon, and here our R1 is 2 degree carbon. So here 3 degree carbon and here 2 degree carbon. When 3 degree carbon shift to this carbon, it is favorable cation, because so this bond break very easily, so this bond displacement and form new CO bond. So here R2 group shift to this oxygen atom, and this oxygen oxygen bond break, and these bond electrons shift to this oxygen atom. So which structure after step 3? So here one, here carbonyl group attached with R1, and this carbonyl carbon attached with oxygen, and this oxygen attached with R2 group, and here our carboxylate ion form. Here, and step 4, electrons from the carboxylate attack the proton, resulting in acid base reaction occur, and this will attack on this proton and here acid base reaction. After this acid base reaction, we get one ester and one carboxylic acid. So here we get one ester group and one acid. So after the ester formation, here they give one lithium aluminum hydride. So we all know lithium aluminum hydride, it is a very good reducing agent. It always reduce carbonyl group and reduce esters also into alcohol. So here this ester react with lithium aluminum hydride, so this bond will break, and here one, so this group convert into alcohol, and this group also convert into alcohol. So here we get R1 OH, and here OH R2. We draw our product in this form. This is our R1. At R1 we get OH, this is our R1. This carbonyl group convert into OH, so here CH2 OH, and this R2 group attach with OH, and we draw our final product like this also. Here we get 5-member ring. So first we draw 5-member ring, 1 2 3 4 5. Here we saw if we give number, so if we give number like this, here we draw 1 2 and 3. So this is our 1 2 and 3. We saw here on bridgehead position they give this group, and C1 carbon we get one OH group, and C3 carbon we get CH2 CH2 OH. So this is our final product. When lithium aluminum hydride react with ester, that time stereo chemistry play important role. This always in this kind of compound, this bridgehead position is upward direction. So when we check stereochemistry of our product, if we check the stereochemistry of our product, here we saw this group present on a bridgehead position. If we draw bridgehead position this, so after attack of lithium aluminum hydride is it always attack on exoside. So our hydroxyl group on wedge position comes on wedge position. So here we check in option number B and option number C. In option number B, in option number, if we check on 1,3 position, they give hydroxyl group, which is correct. But here we saw in hydroxyl group, here our hydroxyl group attached with 2 carbons. But if we check in given option, only option number B have 2 CS2 group. In option number C, only they give 1 CS2 and they uh, missed 1 CS. So this option also we can eliminate very easily. So our option number B is correct. In examination, when we want to this kind of question solve in examination, we want to solve this question very fast. So we can solve easily because metachlorobenzoic acid, if we saw in examination, metachloroperbenzoic acid react with carbonyl group, always where villiger oxidation happen, and oxidative cleavage of carbon-carbon bond adjacent to a carbonyl group, and here carbonyl group convert into ester. If you saw ketone, cyclic ketone, and they give metachloroperbenzoic acid, you convert cyclic ketone into a ester. And where you add oxygen, you check always degree of carbon. With higher degree of carbon attached with carbonyl group, that bond break very easily, so oxygen attach with that bond. So here you saw 3 degree and 2 degree the carbon they give, so always attach one oxygen to this bond, and you solve this reaction in few seconds. You attach one oxygen here, and then react with lithium aluminum hydride. You know lithium aluminum hydride convert ester into alcohol. So here ester, after esterification, you lithium aluminum hydride, it is a distributor of alcohol. So always added hydroxyl group which bond you break. So here you this bond you break, here add one hydroxyl group and attach one hydroxyl group here. So you get your answer in few seconds.